Next up, we will dive into the world of smart farming. Agricultural equipment today is more digital and connected than ever, and that brings also new risks. Our speakers from Lime Security analyzed an aftermarket steering kit for tractors and uncovered vulnerabilities that allow global tracking and even manipulations. Please welcome now Felix Eberstaller again and his partner Bernhard Rader with their talk Tracking the Tractors, Analyzing Smart Farming Automation Systems for Fun and Profit. Welcome.
Okay, good afternoon and welcome to Tracking the Tractors. My name is Felix, already here. I'm here with my colleague Bernhard, and together we have Lime Security. And we had the pleasure to work with some smart farming equipment. It was a lot of fun, and it's kind of profit that we are now allowed to talk about this on IT-SECX. Well, smart farming. Oh, is this the presenter? Okay, so smart farming in general is currently a hot topic. While every aspect of normal operation of a farmer can now be augmented with digital technologies. You have, for example, drone-assisted farming. You have precision farming, where a farmer can use precision machinery, like a tractor with special equipment, to automatically drive on his field. Also, you have smart farm management and also sometimes AI integrations in farming. So all these digital technologies in farming is creating a new digital attack surface that has not been there anymore. So you can forget about this romantic image of a tractor and a farmer and his machine driving on his field. These are now high-tech, interconnected devices. And there is also some active research in there on these topics. Last year on DEFCON 30, SICOS presented a POC where he routed a John Deere tractor and played Doom on it, which is a pretty cool POC. And also there are active attacks in farming equipment. For example, last year, farming system in Switzerland got ransomware, but this was not just any computer, this was the computer of the milking robot. And this robot had also the task to take vital values of the cows. So a cow got sick, nobody noticed this, and then the cow died. And that's probably one of the most unexpected ransomware impacts I've ever heard. But in general, if you have a tractor and you want to make it smart, you have two options. Either you buy a completely new tractor, that's quite expensive because a new tractor with this automation costs about €250,000, or starts at this price. Or you buy a post-market steering system, for example, like this one here from FG Dynamics, FGD82. On the right side, you see our demonstrator. This is also at the booth in the hall. And this is just a steering system, it consists of a steering wheel, which has a motor in it, and a tablet, and a GPS antenna, and some other sensors. So as a farmer, you can just switch your old steering system. So pull off the wheel, put on this wheel, and next time you drive to your field, you can just map the field digital. And because the system has high precision GPS, it can tell exactly where your tractor is standing. And next time you hit the play button, it automatically drives on the field automatically in a certain pattern, which is a great system for automation because it can also integrate system that's being integrated in the tractor via ISO-bus, which is like CAN bus for tractors. And this ISO-bus integration, for example, allows you to automate the plow, for example, to say, hey, I want to plow this field in a certain pattern, completely automated, which is kind of cool. And farmers really like to use the system. However, it has some vulnerabilities.
Thank you, Felix. So hello also from my side. Let's begin with a rough overview of our components here in our AT2 system. Our AT2 system consists of three main components. We have our motor control on the steering wheel, we have our GPS antenna on top, and we have our AT2 Android tablet, which is situated in the farmer's cabinet from the farmer. Our AT2 system gets its GPS coordinates from the satellite in the orbit and communicates them via HTTPS and MQTT to the cloud situated in China. MQTT is a lightweight messaging protocol which is commonly used in IoT products and where different MQTT clients communicate with each other via a central broker. The AT2 system gets its uplink either via Wi-Fi or a SIM card. So our main focus here was immediately on the cloud connection of the system. Let's have a look. So what we found immediately was that our system, our 82 system, communicates, well, as expected, to the cloud via TLS, with the TLS on the MQTT port 8883. But since this is TLS encrypted traffic, we wanted to have the clear text for us, for analysis. For this, we tried a sophisticated approach. For this, we used the tool QSSL-C audit to test the MQTT client for all kinds of TLS configuration flaws and TLS validation errors. And we didn't have to wait long, since the MQTT client is not validating the server at all, which enabled us to potentially intercept the traffic and look at our traffic in clear text. So this is what we tried immediately. We opened a TLS socket on port 8883, and what it got us was this juicy MQTT request here. What we see in this MQTT request, we see in green here this MQTT client ID, which is essentially a user agent, and our MQTT user credentials. The MQTT client ID consists of a product ID, a serial number, and a timestamp. What immediately looked to us was that the product ID was the same as the username. So with this, we thought we have everything. Let's try to connect to our MQTT broker. Well, turned out we also needed some kind of TLS certificate. So how do we get that now? For this, we used Rader to hook the Java native key store functions from our Android 82 tablet to get our TLS certificate. Rader is a dynamic instrumentation toolkit used to inject scripts into application during runtime. So with this, we have now finally everything to successfully connect to our MQTT broker. For this, we use the MQTT Explorer application to connect to the broker and see what our tractor is communicating to the cloud. What we see here is that our very sensitive GPS coordinates are communicated every second through this worklog MQTT topic. An MQTT topic is basically an address on this MQTT server where one client can publish data to, and other MQTT clients can subscribe data from. Where an MQTT client now subscribes new data to the topic, the broker also forwards this data to all subscribers of this topic. So we now have full vision of what our tractor is communicating. What about other tractors? So at first we tried to subscribe to invalid tractors. Well, turned out the broker was okay with that. And then we tried to subscribe to topics of valid tractors. Surprisingly, we also got data in return here. And we tried to take it even a step further to ask ourselves, can we impersonate all the tractors all at once? Well, turned out, yes, we can. With this hashtag here, which is essentially a multi-level wildcard, which enabled us to recursively subscribe to all these topics of this MQTT broker. At first, our systems completely crashed, but after giving our systems a bit more resources, we were able to confirm, yes, the broker is sending us all the data to us. Well, now we have a, literally tractor load of data. How do we handle that? Well, for this, we developed a high-performance Python application. We call it the Tractor Kraken, to handle over 100,000 of MQTT messages per second. With this application, we were able to track all our Truck 82 systems in the field from the American broker, the Asian broker, the European broker, and the Russian broker. Okay, a lot of data. Let's zoom out a bit more and see what we have. What we found during our testing periods was that we found that 46,000 systems were online at some point. Of these 46,000 systems, we found 60% of the systems were operating in Asia, mainly China. 33% of the systems were operating in the European Union, and the remaining percent on the rest of the world were here. 1% were located in the US. Based on these very sensitive GPS positions, we were able to locate the home of the farmers, the movement profiles of the farmers, and what kind of land, what kind of field they own. Besides the GPS positions, we also found some tractor IP addresses from the SIM card uplink and some email addresses of the users, and maybe some potential requests from other products we don't know about. Let's look at some interesting move map profiles we found. What we have here is basically a heat map of the systems we found online around the area, around St. Pölten. And let's zoom in a bit more on one specific example. What we're seeing here is a tractor, a farmer using his 82 systems to drive with his tractor on a public road. This poses a huge safety hazard, since a farmer driving his tractor with his 82 system on a public road, and a potential attacker taking over this tractor could cause massive damage to public health, public safety, and people around them. So it turns out this is where you should actually read the fine print of the vendor, where it says in the safety instructions that they should actively turning off the tablet. Well, turning off the tablet here means making it completely powerless, since the 82 tablet and the Android tablet in passive mode still communicates to the MQTT broker. Our GPS positions are, well, itself very sensitive, but they can be also, they are especially sensitive in different regions on this planet. For example, right now in Ukraine, where these very sensitive GPS positions could actively cost lives. Well, besides this work log MQTT topic I talked about, we also found other MQTT topics. For example, this function invoke topic here, as the name suggests, where the vendor could remotely call functions on our online 82 systems, where we found two functions enabled by default, this log function and the send notification function. The send notification function, as the name would suggest, just triggers a message pop-up on our 82 tablet, and the log function logs our 82 Android tablet. And conveniently, only the vendor can unlock it again. We tried both of these commands only on our system, and for this we brought a short demo video. Well, here we have our farmer, like with the testing equipment what we have on our store. Driving on the field, we have a message popper, your tractor will be locked now. And suddenly the 82 tablet is locked, and the farmer has to go manually steering his tractor again. Well, next we thought, okay, we can lock this device, but how about taking over the system itself and remotely take over the steering wheel? This is something my colleague Felix looked more into it.
Thank you, Bernhard. Okay, so we wanted to take steering wheel, but we had to first analyze the system a bit more. So the tablet you saw before, this is an Android system, and it's quite an outdated Android system. However, the vendor did lock it down a bit, so it's not like you can launch anything other than the vendor's app on this. But they didn't lock the system settings. So that meant with the system settings, we could just enable Android debug bridge. And as you know, Android debug bridge, you get at least some shell access. I mean, but it's shell access, but it's not root access. And we always want root access because why not? And also it's for analysis, but yeah. So we lined up some exploits. We knew the Android is outdated, so we were like, yeah, nice, there are some exploits out there, we can just use them. Turns out, it ain't much, but the device was already pre-rooted. And we were wondering, why did the vendor do this? And turns out, the vendor is using root access themselves for accessing sub-devices on the bus of the steering system. And to access a bus in Android, you need raw serial permissions or just root access. So the vendor made their life easier, but they also made our life easier. So within 5 minutes of having the device on our table in the lab, because this was a rental device, so we had to give it back at the end of the week, we had root access. We were like, damn, that was a bit too easy. But this was just the first step into looking into some attack vectors that allowed us to exploit this thing remotely. And we tried a lot of things. So essentially, we tried many things. We tried, for example, are there any services exposed on the network? There weren't any. Can we send a malicious MQTT message to the device that triggers some form of vulnerability? There wasn't anything, because like the command set is so limited, and the parsing is all done in Java and it's pretty safe, that we didn't find anything that can be exploited in a normal state. So what we ended up with is like, when you have physical access to the device, you can just backdoor it. Like, you enable ADB, easy. And the thing is, like, you only have to do this once in the lifetime of the product, because then you can persist yourself on this device. Another thing is via Bluetooth. Because the Android is a bit outdated, it has some well-known Bluetooth vulnerabilities. However, this attack path is also not that great, because like, the exploit is not stable at all. Out of, I think it was 1 to 100 attempts, it took us basically to get this. But we found something different. We found the possibility to do man-in-the-middle, and via the man-in-the-middle, we could replace something that triggers a code execution on the client. And guess what the feature is called? Over the update. For some reason, the vendor really dropped the ball on the over the update feature. They had no TLS, they had no signatures, they had nothing on this. So they just said, hey, you see this request, hey, this is the URL, time to update. And this was rather weak. So if you're man in the middle, you can just replace the response and then run your custom update. However, this is hard to exploit at scale. But it's well documented that, for example, nation-state actors or advanced threat groups can exploit man-in-the-middle attacks for internet-facing connections. So this can be scaled up. And the best thing is, you can add custom message dialogues to this. So when you are man-in-the-middle, you can, for example, trigger this. Upgrade tips, Black Hat Edition, total on a virus, trust me, I'm a dolphin. And if the farmer says, well, that looks legit, time to update, then he gets an update. But this was a Metapredator update. And suddenly you have, for example, as an example here, you see it was just a Metapredator demo. You see that the URLs are being downloaded with a bad APK, and then you get the Metapredator session. Okay, so it is possible via the network to just man in the middle of this thing and then get root access on this, because it's already pre-routed. But how about steering? Well, it's complicated. Because we are here on the left side of the Android tablet, but there are many components within the system. There's like ECU, which is an embedded device, and which is basically the steering system itself, like the brain of the system. Then we have the MCU, which is kind of the system that really does the steering and also takes input from the IMU, which is an orientation sensor. And all these embedded systems play together and then do the steering. So it's not like the Android tablet telling the steering wheel left or right. It's more like it's telling this complex system of small embedded devices to do some form of steering. Well, the thing is, like as I mentioned before, this was a rental device, so we shouldn't destroy it. So we didn't do any memory dumping, we didn't do any hardware attacks on this. So we had only one option. Look at the ARM assembly of the firmware. And we looked at it a lot. But the thing is, like, this small firmware didn't have any symbols, any strings, no nothing. So it was some long nights at looking at ARM assembly. And we came up with the following theory. If we want to know how the packets are being handled, we need to look at the packet handling structure. And this code structure often has a high density of magic bytes and a high density of condition statements. And at some point, we found this function. I mean, it was not that well named, so we had to rename it. But then we were able to derive the protocol which is being spoken to the embedded devices. And turns out this protocol is quite complex. So we see here, for example, a packet with the header and the sequence, and the types of commands that are being allowed here. And you have to have a certain command sequence to implement this. But when you put this all together with the remote exploit, you can take over the steering system. Or is it? No, this was gone too far. Thank you, Bernhard. So in this demonstration, you see the system is just a normal operation. And the attacker already exploited this at this point. But the attacker can just wait at some point to just flip the switch. So this could be, for example, on a public road. And then the system goes completely haywire, it goes completely out of control, does a hard right turn, and that could be on the wrong road, on the wrong time, could be a public safety hazard. And then the farmer is in a tricky situation, because then he has to fight for control of the steering system, or be quick enough to turn off the whole tractor. But this is a split-second decision. Yeah, and this is quite wild, because that's sometimes used in public roads, while not intentionally, but it is active. But this was not the end of it, because, like Bernhard mentioned, the vendor is also building other stuff. And at some point, we saw take photo, and we were like, what's going on? Tractors don't have cameras. Who's taking a photo? And we were like, okay, interesting. But this was like a device that's basically taking a picture, uploading it via the broker, and then sending the URL to a cloud bucket where the picture was uploaded. And we were like, okay, this bucket has to be authorized, because then we could just access the camera feeds of that thing. Well, it turns out it was not authorized, and that led to this slide. So suddenly we had access to thousands of camera feeds worldwide, and this turns out that the same vendor is also building lawnmowers, and suddenly we had access to camera feeds of the lawnmowers across the world. And these are industry-grade lawnmowers, like, for example, for stadiums and things. And we also, on a Sunday afternoon, I took the time and watched a football game in Ireland via this broker. But I don't know who won, because I only saw like a small angle. But it looked fun. And we were like, okay, that has to be it. It cannot get any worse. Well, then we had this thing. Open door, call elevator, closed door, open door. We're like, well, what's going on? Who's driving with the elevator? Well, turns out a robot is driving with the elevator. And this is the same robot that is the same broker, it's the same infrastructure. And so we were quite confident that we would be able to call the same calls, like, for example, call elevator or open door, and use this to open door in China or call an elevator in China or whatever the system is being used. And that would be one hell of a red teaming strategy. If we hack a tractor, get access to some robots, and suddenly open a door in China. So for all red teamers, please take notes. Okay, but that was it with the vulnerabilities, at least. So in general, to close out, digitalization in agriculture is currently a huge topic. While it isn't that reported, we see these technologies emerging more and more. And however, the awareness in this field is not that high. So the farmers, they are not very aware of the technologies they put in these tractors, and they're also not aware of the cybersecurity risks they introduce to this. And in general, there is a lot of potential for security testing. So if you want to hack a cool system, there's a lot of things in agriculture you can look at. And while these examples might be cute, because like it's just a single farmer or some system, at scale, agriculture is still critical infrastructure. So vulnerabilities at scale in this sector can be quite fatal. Okay, I see we are kind of close to time, but I want to just answer the most important question. Does it run Doom? Yes, it does.
Vielen herzlichen Dank, Felix und Bernhard. Es gibt auch gleich mal ein kleines Dankeschön von der FH. Das darf ich gleich mal überreichen, dann kann ich es nämlich nicht vergessen. Und an dieser Stelle gleich die Frage, gibt es denn Fragen von eurer Seite? Was wurde noch nicht beantwortet? Hier vorne.
Ja, ich habe eine Frage. Gab es dafür eigentlich quasi einen Auftraggeber oder war das jetzt quasi ein Forschungsprojekt?
Okay, the question was if this was
Ja.
No problem. The question was also if this was a paid project. No, this was a random hackathon event we have, and we just through a friend got access to the system, and we thought, oh, that's funny, and we hacked it.
So, are there any other questions here?
How expensive is that type of autonomous steering?
It costs about €10,000 about. So it is expensive, but for farming, but in the scale of farm equipment, it's not that much.
It's cheaper than a new tractor, 100s of thousands. Yeah.
Another one in the back?
What did you do now with this information? Did you inform the vendor, or are these systems still vulnerable out there?
That's a complex question. How much time do we have left?
Maybe the result just.
Maybe if you come by to a booth, I will explain you in detail how the whole vulnerability disclosure went, because it was quite an adventure.
There's another one, yeah.
So you mentioned only the vendor can unlock the device. Did you brick the borrowed one, or were you able to
The question was if we bricked our device now.
If the lock.
Yeah. Yeah, well, this was because per default only the vendor should have access to the MQTT broker, and there were also some requests via this MQTT broker, which could potentially then unlock this device again. So we are, yes, to answer your question, yes, we were able to unlock our device again.
Are there any other questions, or is everybody starting to talk about how the vendor has reacted afterwards.
Please for a better story for afterwards.
Yeah. So, yeah, then thank you very much, Felix and Bernhard, for your very interesting talk to see how that works when you try to take over a tractor and what happens then. Thank you very much.